beautiful people, and welcome. In this video, we are talking about graphing exponential functions. So we started with geometric sequences. We have written the formulas for geometric sequences. We have found out the terms in certain position numbers. But now we're going to take that sequence, that formula, and we're going to graph it. So we're graphing the geometric sequences on a line. However, we are graphing exponential functions. The geometric sequence is an exponential function. Okay, so the first thing I want to talk to you about is domain and range. You will need to memorize this. Okay, I can't stress this enough. Any other class that you take ever and ever and ever will always include domain and range. It's the number one thing that you really truly need to know. So domain is defined as all possible x values, and range is all possible y values. So notice that domain has a relationship with the x values, the range has a relationship with the y values. So another way that you can think of domain and range, domain is going to be your inputs, range are going to be your outputs. So whatever you input into the domain, your x values, out comes your y values or your outputs. So how would this look like? When we're talking about domain and range, your inputs and outputs, we're talking about possibilities on the graph. So for example, I'm going to just give you some points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So let's say we have a line. Let me change my colors here. Let's say we have a line. So there's a point here. There's a point, oh, I don't know, here. And there's a point. Let's do a curve. I want to do something a little bit more random. Like this, and then this one. Let's just do that. Let's do these 3 points. So we're asking, let's do an example. What is the domain of these 3 points, of this graph? What are the domains? So for your domain, you're going to list all of the possibilities. So you're going to look at your x-axis for all of your x values. So I'm going to list them. Here I have, what do I have? 1, this is -3, so this is -3, 1. This one here is 1, 2. This one is 3, 1, 2, 3, 4. So for your domain, your inputs are your x values. For your range, your outputs are your y values. So for all possible x values, you're going to write them in order without repeats. We already did writing domain and range before, so it's the same thing. So you're going to put little curly brackets, and you're going to write all of the possible x values. So in this case, -3, 1, 3. Remember, there are no repeats. They have to be in order from least to greatest. So there are no repeats, even though you can get multiple numbers. So let's say we have another point here. It would become not a function, but you are not writing repeats. So now let's talk about the range. Same thing, squiggly brackets. And we're talking about all of our y values. I have 1, 2, and 4. Again, from least to greatest. There are no repeated numbers, and you have squiggly lines. Now, the domain and range kind of change depending on if you have a continuous or a discrete graph. Now, this right here is called a discrete graph. Now, what does it mean when you have something that is discrete or continuous. Let's go ahead and shift up. For continuous, the points are all connected. So that means the range and domain are all of the points, unless there's something that is excluded. So for what we're dealing with when we are going to be graphing these exponential functions, it is continuous when the domain, so when the x values are not given. That means you choose your own x values to use. For example, let's say I choose something and I get something like this. Those are the values that I chose. Again, you're going to plug them into the equation, but I'm just giving you an example. And you would connect them because it is continuous. You can choose whatever number you want. If you want negative 374.65735, you have that option. I don't recommend that because it's going to make your life challenging, but you have that option. You choose whatever you want, love. Now for a discrete graph, which is what we had here, notice that the points are not connected. So for discrete graphs, the points are not connected. That means when you're doing these problems, graphing exponential functions, the domain or the x values are given. You don't have a choice but to use. You really want to use 2 as an x value, but they do not give you 2, then you cannot use that number. You have to use what is given. And you only get to use what is given. So let's say, for an example, they give you a domain of, well, let's go ahead and use the one above. -3, 1, 3. So if they give you that domain, you have to be able to graph it. Let me actually copy the one before. I want to make sure I get it around the same height. And you cannot graph it. This should be a squiggly line, squiggly bracket. You cannot connect it. This is discrete. The domain is given. For continuous, the domain is not given. You choose whatever you want. So for the continuous, when we're going to be working on it, you're going to be using a T-chart for this one too. But for the, let me pause for a second. And the reason I want to pause for a second is because I feel like I'm going back and forth. Okay. If they give you the domain, you're going to use a T-chart for discrete, and you're going to use your given domain as your x values to solve for things. If they do not give you the domain, you get to choose whatever you want. So if you want -3, 1, let's do -2, -1, 0, 1, 2, 3, etc. You can choose whatever you want. You can choose any numbers that you really want. Okay, so let's go ahead and do a quick recap. For domain, let me zoom in. For domain, it is all of the possible x values. So if they give you the domain, that is a discrete graph. The points are not connected. The domain is given, and you only get to use what is given. For continuous, the points are all connected. The domain values are not given, and you get to choose whatever numbers you want, and then you get to connect those points. All right, beautiful people, I'm going to wrap up this video. In the next video, we're going to talk about all of the examples to graphing exponential functions.